In the previous video, you have learned how to convert non-base SI unit to base SI unit. So you have learned about derived units, okay? But why do we care whether the derived units have the same base SI unit? Because we want to make sure that all equations that we use in physics are homogeneous. What? Homo sapiens? Homo sapiens is humans lah. Homogeneous means every single term, each term has the same base SI unit. Okay, do you know why homogeneous equation or homogeneity is so important? Because if equation is valid, it has to be homogeneous. What am I talking about? Let me show you. Example. So you may or may not know this equation. V square is U square plus 2AS. Or maybe I plug this equation from thin air, okay? So V and U are symbols for speed, okay? Speed or velocity. So if I look at base units for each term, this base unit will be meter per second whole thing square. The base unit for U square will be meter per second whole thing square. And then there's no unit for 2. So what I have left is acceleration, meter per second square, times s is distance m. So if you open up the brackets, right, you will notice that this is m square s negative 2, this is m square s negative 2, and this is m square s negative 2. So all the terms have the same base SI unit, every single term. All these 3 terms have same base SI unit. Teacher, does it mean that the equation is valid? Not necessarily, because if I don't know, maybe I forgotten to write the 2. Will I change any of these units? Will I change this term? No. So in short, correct equation, base SI unit is the same. Okay, just because the base SI unit is the same doesn't mean the equation is correct. So I'm going to draw a Venn diagram for you, and then I'll give you a bit lame analogy. So this large circle shows homogeneous equation. Units means, again, just a reminder, it has the same base SI. But just because it has the same base SI doesn't mean that it is valid. So valid equation must be homogeneous. The units must check out. Because when you add 2 physical quantities like this, okay, you cannot just simply add 2 things that don't have the same units. You cannot take 2 kg plus 3 meter. It doesn't make sense. You take 2 kilogram of durian plus 3 meter of distance. What does that even mean? It doesn't mean anything. So for equation to be valid, the units must all be the same, every single term. But just because every single term have the same unit doesn't mean that it is valid, because sometimes there are dimensionless or unitless constant. So how to make the equation valid? We do experiment. We check using experimental methods that we will cover a lot in your A2. So right here, A2 paper 5, you get to design your own experiment to test the validity of your instrument. Then you're like, teacher, I cannot wait for A2. I want to test now. Now test. Okay, can. We can also test using lab instruments. That means you do the experiment. This is AS paper 3. If your country don't have lockdown and you have access to your labs, okay? So the only way we can check to make sure the equation is valid, that there is no the dimensionless constant like 2. This one is unitless. Sometimes they want to call it dimensionless constants are also valid. because the tool is not participating in the base SI unit, is to design an experiment, and then after that we test the experiment. Okay, lab testing. Design liao, then only test ma. Where got people test already, then only design one. It's like you want to build a building, you build it, then only design. But wait a second. In A levels, they design for you to follow until you have enough experience point to go to A2 and paper 5, and then you design yourself. Alright. Okay. So that is the use of base SI units. Is a checking system for us to make sure that the equation is valid. And also for us to determine, let's say for example, you're like, I wonder whether this exponent should be square or power 1 or power 3, I don't know. Check the base SI unit. Okay, I'm going to do some examples now so you can see exactly what I mean. So this is an example from Winter 19 paper 11. Okay, let's read the question. The speed of a wave, okay, we have speed, in deep waters depends on the wavelength L, okay, and the acceleration of free fall G. What is the possible equation for the speed V of the wave? Okay, so remember homogeneous equation, meaning each term must have the same base SI unit. And then, teacher, this equation only got 2 terms. Yeah lah, easy lah, only got 2 terms what? So if there's only 2 terms, we check both terms. So I think I will check the left-hand side first. Left-hand side. So I'll write here, base SI for V. Okay, the base SI for V directly is -1. Okay, so this is -1. Then we go and teacher, so many things. Okay, you chill first. So you're doing objective, right? So you see, there's a lot of GL, or G over L, G over L. So here's my Miss Lee method lah. I'm not going to test one by one. I'm going to see what GL and G over L is, and then I'll figure it out. Teacher, we don't have to care about the 2 pi, 4 pi square, all that. No need. Because what is this 2 pi, 4 pi square? Got unit or not? Got unit or not? No unit. No unit, we don't care for unit analysis. So 2 and pi or whatever, this one are all unitless. So, okay, thanks, bye. Don't care about them. All right. So now we do right-hand side. But I'm going to be a bit smart. I'm just going to figure out what is GL, grand legend, and what is G over L. All right. So what is G? Acceleration is G. So from here, you can see that G would be -2 because the base SI unit for acceleration is -2. Wavelength is M. So this is M. Meaning GL is actually M square S -2. Okay, so if I want M square S -2 to be equal to the original MS -1, I need to square root, right? The 2 must become 1. The -2 must be -1. What do? We square root. So hence, again, this is objective. The way you write working, not that important. Paper 2 matters, paper 1, nah. Alright, so hence, if I go and take the base unit for GL, square root of GL, I will square root M square S -2. And what happens when I square root this, ladies and gentlemen? I'll get M S -1. Hey, teacher, same, correct. So we take GL with a square root. The answer is A. GL with the square root. Teacher, the 2 pi leh? Remember, 2 pi no unit. Don't care. Whether it's there, it's not there, doesn't matter. So this is what I mean by just because the units are correct doesn't mean the equation is correct. But if the equation is correct, the unit must be correct. Okay, so right now this unit will be correct, or rather this equation will be correct. And then you will be thinking, teacher, I don't feel safe. Can we check the G over L? Can. So I'm just going to write here. This side here, this will be ms negative 1. If you look at this one, this will be m square s negative 2. So this is out. Okay, what about G over L? G is ms negative 2 and L was m. The m and m can cancel. Wow, cannot, totally cannot. You know why? Because the base SI unit have a meter. See here? Where can cancel like that? Hello, cannot. So after you cancel, whether you square root or you don't square root, you definitely will not get the answer. Okay, so that is how we arrive at 8 for this question. Next one. Second example. This is a bit more recent from Winter 20 Paper 1-2. Okay, so here, once again, we are at the speed of the waves. Okay, on the stretch wire is given by this equation. If you cannot see the equation because the term is very small, I write for you, okay? V is equal to TP, not toilet paper, but 10T to the power of P, and mu to the power of Q. All right, so what's T? Question will always tell you what, don't worry. T is tension in the wire. So for those of you who may or may not know this, tension is a type of force. No, tension is a type of force. And because it's a type of force, the base SI unit is the same base SI unit for force. Okay, so mu is this mass per unit length. Teacher, why mass per unit length? Now it's not, chapter 1 is not really the time to ask why the equation like that. Although that is a very good question, please keep in a box, precious box, and ask in other chapters. Okay, but here mu is mass per unit length. Just follow the question, because what are we testing, or what are we evaluating, or what are we learning now? Not so much as how can my sword fight the monster, but how to use a sword. So not so much as why is mu that way, but how do I use my new skill to derive base units to cross-check equation or to come up with power. So normally, right, when scientists do or they observe a phenomena, they be thinking to themselves, I see the speed on this string or this wire, like the guitar wire, okay? And I feel that the speed or the pitch of the sound depends on how tightly I tighten the wire fretboard and how thick the wire is. So how tight is the wire tightened, or how thick is the string? So those of you who play guitars or have seen a guitar before, you will know what I mean. You can adjust the tension in the guitar wire on the fretboard, you know, the part, the knobs there that you can turn. I don't have a guitar. Miss Ellie has a guitar. Okay, so if you change the tension, maybe the speed will change because I hear different sound, different pitch. If I have a thicker wire, the sound also sounds different. So maybe because of this, the speed of the waves are different. I don't know, I'm just guessing. But you see, when we guess something, we can guess, but the unit must be the same. So then the scientists look at this and I'm like, I wonder what P and Q is. Is it power 1, power 2, power half? You see, there's a lot of half on tables at the side. So this is why we do dimensional or unit analysis to help us decide what power the physical quantity should be. Okay, so we use to verify and to decide. So in this case, I'm just going to list down the base SI unit. So step 1, what are the base SI units? I'm going to start from the left-hand side. V. Velocity, speed, meter per second. So whatever T mu is, it has to be meter per second, okay? All right, so now I'm going to continue with right-hand side. Okay, I'm going to write here, RHS. So you have tension to the power of P and mu to the power of Q. Tension is force. So I'm going to change it directly to base SI unit. Quick reminder, F is equal to MA. So I will use kg meter per second square. Okay. Power P. So this is T. This whole thing is T. Okay. What is mu? Mu is mass per unit length. So I'm going to plug mu in. Mu here, this mu, kg mass per unit length, meter. Okay, so this one is mass over length, which is kg meter -1 or kg per meter. And then you will notice something quite interesting. Oh, wait. Where's my Q? Q went for a walk. Q is here. Okay. So the first thing I do is I don't panic first. I know whatever that's on the left must work out the same here. So whatever we do to these two terms, when I multiply them, I should get back meter per second. Teacher, impossible. You see got kg, you see got kg. Okay, you chill first. Chill. Whenever we see the same term, what do we do? Okay, so sidebar. If let's say I have AB to the power of P multiplied by A over C to the power of Q. How do we simplify this? You can treat P and Q and your units like algebra. Okay, so you see the A here, you see the A here, you do a gathering of A's, right? Put all the A together. And then how do we combine the prefix? Multiply is P plus Q. If like that also cannot, don't worry. We can always go back to basics. We can go AB squared times A over C power 4. So A power 2 times A power 4 will be equal to A power 6. Because 6 is 2 plus 4. Okay? So in this case, this is your A. And then I will add P plus Q. Can I? Okay. So from here, I can go back to the same thing. My common term is kg. So kg come out, please. Bracket. P, kg power P times kg power Q is kg. P plus Q. A power P times A power Q is A, P plus Q. Cannot. A power 2 times A power 4 is A power 6. Okay, so it's okay to break things down until your brain get used to it. Alright, so we have kg, P plus Q. Then your teacher, Nani, where got kg? Where? No kg. Okay, never mind. If there's no kg, means power what? Power 0. So on this side, I can actually write this unit as kg power 0 meter second -1. And you're like, teacher, can meh? Kg power 0 leh. Anything power 0 is 1. A power 0 is 1. Anything power 0 is 1. You go check your calculator lah, okay. So this means if I compare them, what will I have? The first clue or first hint I have is this P plus Q, if you look at this prefix here, P plus Q, it must be 0. So P plus Q must be equal to 0. Now you look at this MCQ. Which P and Q is 0, 1? A is wrong liao lor. -half, where got 0? Half, where got 0? Wrong. You are left with 2. It's either P is -half or Q is -half. But don't forget, we got another term we haven't checked yet. Okay, we still have M and we still have S. I'm now going to check M. Okay, and to make my life a bit easy, I'm going to change the example a bit, okay? Go put B here, now put B here. What to do with B? Right now, your B is B to the power of P multiply 1 over B to the power of Q. So this multiply 1 over is divided, you're right, divided by B, or B power Q, or you could say negative, teacher, correct, negative. So here you will multiply B, let's put B, okay, and then because of the 1 over, this will be P minus Q. All right, just doing a bit of algebra sidetrack for you. Okay, so here, if you cannot, then it's B squared over B power 4 ma. You see this? So isn't this, you know, A to the power of 6 times B to the power of 2 minus 4? Okay, so divide is minus P minus Q. So in that case, right, I can now do a quick gathering for meter. There's meter here. There's also meter here. Put them together. Meter P minus Q. Let's check on it. P minus Q, if I look at it, change color. You see it's P minus Q. You see it's M. We compare the indices. M to the power of 1 must be equal to M to the power of P minus Q. So you can say 1 is equal to P minus Q. Okay, we can check. Let's check the first one. Negative half minus negative half. I get 1 meh? No. So this is out. Because negative half minus negative half, I get negative 1. So cannot lah. And then for C, half minus negative half, I get 1. The answer is C. Okay, let me write it down for you. Okay, so I created a bit more space so you can check if you need it. If not, you can move on to the next video. P plus Q here is 0. So P plus Q here is not 0. It's negative 1. This is 0, this is 0, this is 1. Which is why we eliminate this and we eliminated this. Okay, P minus Q is 1. In this case, P minus Q is negative 1. This is out already, lor. Okay, this one, P minus Q is negative half. Actually, I don't have to test this two already. Negative half minus half. Nah, minus half is negative 1. So this is out. And for this one, half minus negative half, this is 1. So the answer is C. Okay, so yes, physics is very maths intensive now. So you gotta ready your brain because step by step working may not be here for long. All right. So if you think this question is quite long, yes, first time you do something, sure, very long one ma, right? But as you practice, do more past years, you should be fine. And another last note is you can always double check your answers. Okay, because there's another term that we haven't disturbed yet, which is S. So just for the sake of completion, okay, I'm going to have S here. This S is negative 2P. So finally, I can say negative 1 must be equal to negative 2P. This one seems easier, lecture. Of course lah. I leave the easiest one for myself. So negative 1 is equal to negative 2P. So what is your P? P is equal to half. Okay, so try and error. Is P equal to half? Let's pray hard. Yes, P is equal to half. That will mean that our answer is C. Okay, so that's it for base SI unit and derived SI unit. Okay, so the important thing to understand here is we are going to use some indices or index to help us simplify the units. And the main function of deriving base SI units is to compare terms inside an equation because they have to be the same base unit for it to apply. So like for this question, what I did was I took everything on the left and found the base SI unit. Left hand side and right hand side must be the same. Left hand side and right hand side must be the same. After I put them side by side, I can compare. So I pull everything out and then I look at the options in my MCQ. If this comes out in your paper 2, then you will have to actually show the working. Like P is equal to half and sub back into this equation to find Q. Okay, so if this is paper 2, the working will look like this. And then you just show the comparison and sub back inside. Okay, and that's it for this video. I'll see you in the next one. Go do some questions. Your turn now. Go practice. Bye-bye.